Welcome back to the Curiosity Workshop. It's a beautiful day here in Wichita, Kansas. Today we're going to talk about another wrapper I wrote for handling potentiometers. To use this wrapper, you'll need to include XPL potentiometers.h. You can also specify the maximum number of potentiometers that you want to use. It defaults to 10 if you don't specify. In this case, I'm only using 2, but I specified 3. I have 2 analog pins that I'm using. These pins will be hooked up to the wiper position on 2 linear slide potentiometers. Pin A0 will be the throttle, pin A1 will be the mixture. It's optional to have a handler here. You can also specify null when we're defining the pots. If you define one, anything that happens on the potentiometer, well, when changes are detected, this handler will be called. This creates an instance of the potentiometer handler. We specify the handler if we're going to use one, otherwise you could put null in there if you're not interested in the information to process. This is all the normal stuff. We do need to call pot.begin and tell it the instance of XPlane or the XPlane Pro that we're using, so that it knows how to make calls. In the loop, the normal xp.x loop is there. We also need to call the pots.check function, which samples all of the potentiometers that we've registered, detects if things have changed, and then it changes the appropriate data ref, and also if we've specified a handler, it calls the handler with that information. When we're registering our devices in XPlane Pro, at the beginning, or if an airplane has changed, XPL Pro calls it XPL register. We need to call pots.clear because we're going to register them again. We don't want to continue to add. The parameter here is the pin that we want to use. In that case, we defined it as A0. What we want to do, we want to change data ref. And then here's the data ref that we're going to change. In this case, there is a data ref that allows us to change all throttles on the aircraft all at one time. These parameters here, this tells the handler that we want to update no more than every 10 milliseconds. The next 4 are for scaling. The potentiometer on at least on a mega board will change from 0 to 1024 as it goes through the travel. We want to convert that to a number between 0 and 1 when we send it to XPlane. The data that's sent is actually the 0 to 1024. When it sends it to XPlane, we've registered that we want the scaling done, and it happens within the plugin to save processing time on the Arduino. So basically what this is saying is no more than every 10 milliseconds a potentiometer will be read that will give us a value between 0 and 1024, and we want to convert that to a floating point number between 0 and 1, which is what the data ref is expecting. Same thing here. Pin mixture is A1 that we defined. We want to update a data ref with it, and here's the data ref for changing the mixture. Same thing on the update rate and also the scaling. Here's the handler that we said that we sent to the potentiometer handler. If we need it, we can put this in here. It sends the pin and the value that was changed. I haven't come up with anything cool to do with this at this point. But if you had something cool you wanted to do, you would make it happen here. If something is detected on the throttle potentiometer, if it detects a change, it's going to call this. It will send which pin has changed and what the new value is, and then we can process based on that. If you want the potentiometer wrapper just to go ahead and update XPlane, it does that for you automatically. You may not even need to do this ever. I have a mega attached here. I'm going to go ahead and send this to it. Looks like it's all good. Let's load X-Plane, see what happens. I have X-Plane loaded with the bearing. The mixture is apparently in the cutoff position, so that's why the airplane just died. But that's okay. You can see that I have my prototype button box all set up here. I have 2 linear potentiometers on there. There are pictures that accompany the sample sketch for this. It's pretty simple wiring. There's also a circuit diagram that accompanies the example. Anyway, when I slide the throttle one up, the throttle follows. When I slide the mixture up, the mixture follows. That's really all there is to it. Links to the build are in the description box for this video, as well as a list of components that we use. Your like on our video and your subscription to our channel helps us more than you can possibly imagine, so please do so if you have the desire to do it. Otherwise, I'll see you in the next video, and I'm not sure what that's going to be yet, but it'll be coming soon. Talk to you then. Bye.